Hi, my name is Andrew McLaren, and I want to help you with slope, which we oftentimes see in the y is equal to mx plus b formula. And I think that the problem that I have with how it's normally taught is this whole rise over run. When I was learning that, I would flip rise over run at least some of the time, and I know a lot of my students do the same thing. So I was tutoring for this, and it really helped some people out how I emphasized units. And then I brought this idea of using units as a focus for these problems into when I was subbing, and the students like they got it. And it was incredible the amount of growth that they had in just like a 20-minute conversation. They started being very consistent in how they were working through slope. So you oftentimes will see in high school, they'll teach M a slightly different way. This M concept is usually emphasized as a change in y over a change in x. And I think that that's okay because you can use that to kind of see that the x's are going to cancel out, and we can talk about that in terms of units. So if we have something where you've got a cost of, let's say, like a burrito costing like $10. So for one burrito, then you've got this relationship that we have units in it. So if you're trying to go from y to x, it kind of depends on which one you define as x and which one you define as y. But if we were trying to go from x being burritos, so if we've got x right here as the unit of burrito, then y could be the cost that you're spending on said burritos. So you can think about this in terms of units where you've got your slope as the burritos down here and the cost of it being up top. And when you have, let's say, two burritos, then that ends up canceling out the units. So you can kind of see how the burrito down up top and in the x part of the equation, they cancel each other out. Now this is kind of like if you had 3 times 2 all over 2, those 2's cancel each other out. Same sort of thing, we've got like burritos in the numerator and the denominator, because you can think of 2 burritos as 2 burritos over 1. You combine numerators, you combine denominators, and the burrito variable or unit ends up canceling itself out. So in the end, you get $20. So if you use units to cancel out these things, you're going to end up placing the run or the x movement down the bottom, and the rise or that movement up and down being in the units of the y-axis on the top. So rise over run, yes, it works kind of nicely, but if you actually use units, this is quite useful. You can also think about this in terms of like speed and distance. So let's say that you are starting at like 100 meters, like that's your initial position, and you're trying to figure out what where you are after some time. So let's say that you've got a y is equal to mx plus b, and oftentimes position right here is measured with like x. So this can be a little bit confusing. But let's say that you've got some speed that you're traveling or velocity, and you're saying that you're going negative 10 meters per second. So you started at 100 meters forward from, let's say, a car, and then you're coming towards that car now. And we can use this idea of slope to get between position and time. Because velocity has some units for distance and some units for time, we can use that in a problem like this. So you could say maybe you're working with the slope negative 10 meters per second. And if that's the case, you can see seconds are down here, so it should be multiplied by seconds. So you could say like maybe if I've gone for 3 seconds, I've traveled back 30 meters. So maybe if I'm thinking about this in terms of time, then this could then be distance. And this can be a little bit confusing because sometimes position is marked as like an x variable, but you're solving for it in terms of y, in terms of this traditional way of setting up these equations. So you can say like, oh, I want to know where I am after some time. And I started off at 100 meters. So that's like my initial position. That's like my B component. When you end up keeping track of units, you can see how the seconds end up canceling out in this part of the problem so that you've gone back 30 meters after 3 seconds, but you were starting at 100 meters away. So your final position ends up being 70 meters after those 3 seconds. And so the question on these types of problems is like, how can I cancel out units to go from one place to the other? How can I change these this rise over run mentality to thinking about canceling out units? And as you can see, like the in this problem, the change in y over the change in x, that was measured in the units of meters over seconds. So that meant that the y was talking about distance and the x was talking about time. And if you can kind of shift to using this change in y over change in x with students like right away, and then helping them cancel out units, that can really, really help them out. Now you could also go the other way if you use this like 10 burrito problem, but you set it up a bit differently. So instead of having the burritos in the denominator and the money in the numerator, you could set it up the other way. So if you wanted to work through this problem, but using the money down in the bottom here, that's $10 for one burrito. So you could multiply it and say like maybe I've got like 50 bucks. And I can use those units to cancel out the money, like the $10 and the $50. And you can see that you're going to be able to afford 5 burritos if you were to have $50. So maybe this is a problem where you started off with like $200 and you're asking, well, how much money do I have after I've used like 10 burritos? How much money do I have after I've bought like 12 burritos? So you can set up some problem like that. If you were doing so, you might want to think about y being the money and your y-intercept. It's like when I have 0 burritos, how much money have I spent? So you can set up this problem in the same sort of fashion, but be like, how much money after bought 12 burritos? I start with $200. So in that context of that problem, when you've got the y is equal to mx plus b, if we've spent like nothing on burritos, then the b-intercept is just how much money you have at first. So you can think about like, okay, I've got $200. And then the number of burritos was 12. I'm gonna go with B just to all right, no, let's go with burrito. So we've got the word. So we've got 12 burritos, and now I'm trying to convert using one burrito. Costs $10, and the fact that we have $200 in addition to our burritos. So we had $200 at first. So if you've got this, you're saying this costs 10 burritos or $10 per burrito, but I'm thinking this should actually be a negative number because you're losing $10 every burrito that you're buying. And if we do that, then we've lost $120 when we've bought 12 burritos. So we've got $200, you've lost 120 bucks. You can add those up together and you can get how much money you've got when you've used those 12 burritos. So I'm seeing, I think, 80 bucks being how much money you still have after you spent the money on those 12 burritos. So this rise over run can also be confusing because people will sometimes get confused about rise because this isn't always going up. Sometimes you're spending money or you're losing something. And that's the same sort of idea here where this was not a rise, this was like a falling value. So that can be a bit confusing if you're using the term rise over run. So yeah, focus on units. That change in y over change in x is also an appropriate way of doing this, even when you're first going over this, and it might help students out with their understanding.